Christopher Kyed, a data scientist at Pacific Spatial Solutions, which is a location intelligence company based in Japan. Chris has been working on predicting traffic-related risks based on billions of observations from drive recorders in vehicles. So let's turn over to Chris for this presentation.
Yep, thank you very much, Tyler. And hello, everyone. Thank you for joining. And today I want to talk a little bit about how Fused helps us handle a very massive data set of more than 100 billion points, and how we kind of tackle this together. So let me just jump right into it. Share my screen. Let's see here. Go. Hopefully you should be able to see my screen now. So first, let me just quickly go over the data that we'll be using for our analysis. And what we're trying to achieve is basically find the speeds or the average speeds of all the roads in Japan, and then use this for our traffic risk detection further down the line. The points themselves look something like this. They cover the entirety of Japan, and this is just a very tiny selection of these points. And if we zoom in, we can kind of see how it looks. And you can see there's just a bunch of these points. And this is basically thousands of cars in real time just pinging several times, many times a minute. So every 10 seconds, maybe a few times. And it's thousands of cars pinging several times. I mean, 1,000 of cars pinging many times a minute, every hour. You get the point. The data grows very large, very quick. And as a result, we happen to have this 100 billion point data set over a year. So the UDF that we've written at Fused here, let me show you that now. We'll basically take the data, and for this demonstration purpose, it's just a fraction of the data. And I've done a bit of caching here, a little bit cheating, but just to show you that it does actually work in real time. Here you can see it's updating. But basically what's happening is that Fused is grabbing in this data, and we're using around 1% of the data, which is still a billion points that is being pulled. And then it quickly figures out that we only want the points within this bounding box, and then maps into the road. And what we're looking at is basically these bright colors being high speeds, and these darker purple colors being slower speeds. And the width of the roads here actually show the density of the points. So you can see how the thicker roads here are basically. Let me zoom in a little bit. These thicker roads are actually where we have more points, so that would be more popular roads. So now that you've seen the result here, you can see we have the count and the speed and the width. So now that I've showed you the result, I kind of want to talk about the method we used before and the method we use now with Fused. So we used to use a cloud platform before, and what I found with these big cloud providers is that most of the time you're going to be writing in SQL. You don't have any real-time way of kind of knowing that what you're doing is correct. It's kind of like a black box. So what ended up happening for us is that we created a simplified solution in hopes that we wouldn't have to spend too much processing power down the line. Because if you can't really directly see what, and this is a geospatial problem, if you can't directly see the effects of the tweakings you're making to your logic and your algorithm, then you might be spending hundreds of dollars or maybe even thousands of dollars. And at the end of the day, all this development you make on this algorithm to make it even better, it might not be worth it. So with Fused, since everything is happening in real time, you can actually directly see the changes to the changes you're adding to your code. You can basically see it in the map straight away, and it makes the development process so much more fluid and seamless and easier. And there's no moving data around like there is with other cloud providers. where you got to export it somewhere and then show it in a map, and then you got to clip your data and so on and so forth. So it's just been very, very straightforward to work with Fused, and you can create these amazing visuals that update in real time. So the last thing I want to kind of touch upon is you might be wondering, like, what about the rest of the data, right? This is just a small part. So that's actually the next step. And together with the people from Fused, I can actually hopefully show this. So this is a very much work in progress, which is the reason why I've kind of preloaded it. But I can tell you that this runs in around 1 minute. And you might think that this is just showing the roads the same as before, but this is actually the full data being loaded for this area and bucketed into tiny, tiny, tiny H3 hexagons, size 14. And if we actually take a quick look at the UDFs here and how big they are. So these are two chunks. For the first chunk, we have around 200 million points being bucketed. And for the second chunk, it's around, see, it won't show, but it's basically around 360 billion. So what we're looking at here is 361 million. So basically what we're looking at is 500 million points bucketed into this tiny, tiny H3 index, which we can then use to map to the roads as we did before. And before I didn't get too much into detail about how we actually do this mapping, I would like for people to take a look at the blog due to time constraints. But basically, we use H3 for this process, and that's why I'm showing you that we're able to basically bring in all the points and bucket it into these H3. And it's very interesting to note how you can actually tell which road goes above and which one goes below just from the speed mapping. And this just goes to show that with the precision that we can get through Fused and how much granularity we can use, and if we can use all this data at the same time, it basically makes everything so much easier. And being able to visualize it as well makes you able to create these incredibly in-depth analysis. Yeah, and that's about it. I'm very happy that we've been able to use Fused this efficiently, and can't wait to what else we have in store. Thank you so much.
Thanks for the presentation. I do have one quick question.
Sorry. Yeah, go ahead.
You're basically, my understanding is that you're gathering all this data and aggregating it to make a prediction of vehicle risk along different roads.
Yeah.
Are you actually comparing that to another data set of like observations of vehicle crashes? Or is that future work? Or can you tell?
So basically, you can see this as one part of a longer pipeline, where this is just about finding out the speed of the roads, and the speed then goes into a machine learning pipeline that takes all the features as well, and then it comes with a risk prediction. And the risk prediction is based off of traffic accidents, as you mentioned. So traffic accident roads will be different. Will be the targets, and then speed, which is calculated through this, as well as other variables, then come in to help with that prediction.
All right, thank you.
Yeah.